Okay then. Hello everybody. Thank you all for coming. My name is Matt and I'm from JetBrains, and today I'm going to talk to you about using JetBrains Rider as your default scripting editor for Unity. We'll have a look at some tips and tricks, some getting started, some how to use it, how to get comfortable with the tool, and hopefully we'll see how we can write better code and better scripts with Rider, and how it can help you write better scripts, and how you can hopefully have a better experience while you're doing so. So first of all, what is Rider? So for those who aren't already familiar with Rider, Rider is a cross-platform C# editor with Unity-specific features, and it's based on ReSharper and IntelliJ. There are a couple of things that I want to sort of point to in here. First of all, it's cross-platform. That means it runs on Mac, Windows, and Linux. And it's the same experience across all platforms as well. So we don't offer a stripped-down or alternative version for Mac. What you see on the Mac is what you get on Windows. They're exactly the same feature set and the same experience. I'm demoing everything today on a Mac, mainly because I like them, and it's the same experience. Everything I show you today, you can also do on Windows. It's also a C# editor. I'm calling it a C# editor here. I'm more used to calling it an IDE, an integrated development environment. And the integrated is the key bit there. One of our design goals when we build products at JetBrains, it doesn't matter which language we're talking about, but one of our design goals is to make the user to give the user everything they need to get going and get coding straight out of the box. So we want everything ready for you so that you can just install the tool and run it. We don't want you to spend time installing something and then having to install a whole load of plugins to make it usable. So everything is ready in the box already. So that means we come with editing, refactoring, navigation, but also things like debugging and version control, all built in, all ready to go. We do still have plugins. We've got nearly 1,000 plugins for Rider, including, for example, Python tooling. So if you need to do stuff with AI, for example, which is a big user of Python, you can install that into Rider if you want to. The Unity-specific features are obviously very important, and I'll come back to those. But the other thing I want to point to is that we are based on ReSharper and IntelliJ. And if you are familiar with ReSharper from Visual Studio, it's one of the most popular Visual Studio plugins. It gives you a whole lot of useful information for your code, lots of rich navigation and refactorings. Then Rider is built on top of ReSharper. We're running ReSharper out of process, 64-bit, and we get to use nearly all of the functions that exist in ReSharper as part of Rider. The user interface is based on IntelliJ, and this gives us access to IntelliJ's plugins, for example, but it also gives us a very rich tool system and user interface. So if you're familiar with tools such as WebStorm or Android Studio or IntelliJ IDEA or PyCharm, then you should feel very comfortable with Rider. So I mentioned a minute ago about one of our design goals when we're building the products. One thing we want to do is allow you to focus on the problem you're trying to solve, not the code you're trying to write. We want you to actually be busy thinking about the problem. We'll help you with the code. We'll help you navigate, we'll help you edit, we'll help you build things. With Unity support, we wanted to do something else as well, and we wanted to reduce the amount of time that you spend switching between Unity and the script editor. So Unity is a fantastic environment to work in, and C# is a very good language to work with as well. It's a very strong, it's a strongly typed language, which means the compiler can find a lot of problems for us. And this is all very good until Unity then layers its sort of special magic on top of it, and that can cause issues that we only see at runtime, or that we only see when we swap back to the Unity editor. So we want to try and bring some of those things back into Rider. So we want to be able to show where there are problems in your code before you switch to Unity. So we want to reduce that amount of time you spend switching. So we're going to find these problems before you encounter them at runtime, before you encounter them when you hit play, and we want then to allow you to concentrate your time on writing game logic rather than typing code. Okay, let's move on a bit. There are 2 keyboard shortcuts that I want to teach you about. We have hundreds of keyboard shortcuts. You don't need to learn them all. These are the 2 really important ones. If you've got this, you can then get access to pretty much everything. The first one is Shift, Shift, double shift. If you are familiar with any IntelliJ products, you should be familiar with this. This is where you go to search stuff, where you go and find things. And this will allow you to search everywhere. It'll find anything in your code. It will find classes. It'll find types. It'll find type members. So it'll find properties and methods. But we can also search other things as well. It'll find files, but it'll also even look and search for actions and preferences as well. So here is a great way of being able to go and find something and navigate to somewhere. So Shift, number 1. Number 2 is Alt-Enter. If you're familiar with ReSharper or an IntelliJ-based tool, Alt-Enter will be familiar with you. Alt-Enter is the keyboard shortcut for doing things. So we have the idea of inspections. You're probably familiar with this. If we find something wrong, we'll put a squiggly underline and highlight something in your code. This might be an error, it might be a warning, or it might just be a suggestion that we can do something better here. When you hit Alt-Enter on that inspection, we offer you a menu with a bunch of with some items which allow you to quickly fix the code. But we often have this menu available elsewhere as well. So you can hit Alt-Enter at any point in your code, and there's usually something to do. So for example, in this one, if you hit Alt-Enter, we can change a public interface into an internal interface. One more feature that it's got is at the very bottom just there. You see them. There are 3 items that are always there. 4 items, sorry. Navigate, refactor, inspect, and generate. These are the main entry points into all the functionality that we can do. So we can navigate around your code straight from Alt-Enter. We can refactor your code. We can safely rewrite it. We can inspect your code, look for issues. And finally, we can help you generate code. And again, that's a great entry point of getting into the functionality. The final feature, which is really useful here, is if you can't find an action, you just need to start typing. So if you want to know where rename is, but you can't remember the keyboard shortcut, Alt-Enter and start typing rename. Okay, so how do we get started using Rider with Unity? The easiest thing to do is to hit the Open Solution or Project button. Open an existing solution. If you've got one there, we will just load up that solution. We work with the standard solution files that Unity generates, and we'll open those and run. When we first open a project, one thing's going to happen, and we're going to install a plugin. We will copy a DLL into the folder on the left there. If you can't read that, that says Plugins Editor JetBrains. This is a plugin which is going to help the communication between Unity and Rider, and we can do some fun things with that, and I'll show you some of those shortly. You should ignore this in source control. Don't check this in. We'll look after this. We'll keep it up to date. Don't check it into source control. You'll get a little notification on the side there telling you that it's been done, but other than that, you can forget about it. Of course, if you want to, you can configure things manually through Unity as well. You can browse and go and find the Rider. You can browse and go and find Rider itself, or if it's already installed, you can use the plugin to actually go and just check a checkbox and get it sorted. Okay, enough slides. Okay, so this is Rider now. I'm going to show you then just show you some of the things then running in action. I have a project open already. It's just the tower defense sample from the asset store. I've got it running in Unity behind me here and ready to go. And now we can look around and have a look and see what's going on. So I will start with the same shortcuts I've just shown you. Shift allows you to search. We show a list of files by default, and now we can start typing. And one of the things we can do is we can just start typing words, and that will narrow things down and find it for us. Or we can make it a whole lot easier and just type the initial letters. So we can very quickly navigate around and go and find something. So again, we can start typing something which is going to be an action, and we can invoke an action that we can do at this location. So if I'm on the name of a class, I could type refactor here, and I get my options then for doing refactoring. So there are a number of things we can do here which are interesting. We can enter the name, the initial letters of a class and navigate there quickly. We can also, if we put a colon there, we can say jump me to a specific line. So if you have a stack trace, for example, this is a useful way of getting to a particular line in that file itself. And once you're in a file, we've got a whole lot of navigation options that are available here as well. So I will do my Alt-Enter, and again down the bottom here we've got Navigate To, and this then opens up a context menu. Let me scroll that up a bit more. It gives me a context menu of all the items that I can do at this point, that I can navigate to from here. We have a number of interesting ones which are good, so I can go up and down the class hierarchy, for example, so I can find base items. So I can see here now what classes I am derived from here. We can see there's an item listed in bold. That is something I am directly derived from. Everything else then is indirectly derived. So I can navigate to Input Scheme Switcher, and from here I can do a similar navigation and go and find Derive Symbols. Oh, there's only one there. Let's go find a different one. So if I navigate and go to Derive Symbols, I can see all the items here now that are derived from this class. And again, there are some items in bold. These are directly derived, whereas the items not in bold are indirectly derived. And I can navigate here, or I can also just type in here as well to narrow down that list. If that list is too large, I can quickly find something and get to where it is that I want to go. We have more items in here which are useful. For example, I'll tell you what, let's have a look at something else. So this is kind of navigating to something when you're already there. So you can navigate to a derived type or a base type. If you want to go and find something, for example, tower, here, I want to navigate to there, I can very quickly do that by hitting Control and click, and just click with the mouse and navigate there. I can do a similar thing with Alt-Enter and navigate to, and then just go to declaration. And that will navigate me straight there. So I can easily get around my code based on where I am. So this allows me to understand my code quickly and find where I want to go very quickly. Another item we have in the Navigate menu, which is very, very useful, is this one here, Find Usages of Symbol. This is a great way of finding where this particular piece of code is used in the rest of your project. And when that opens, we get a nice list of items down here of where it's being used. We can have it grouped by folders, or we can have it as a flat list as well. So we can have it grouped how we want to do it so that it's easily readable, or we can have it as a flat list too. And so that shows us where it's being used. If we collapse this for a minute, we can also see that we can group it based on how they are being used as well. So the code, when we open a project, we index all of your code. And we understand the structure of that code, we understand how that code is being used. And we use this for navigation, but we also use this for things such as usages. And we know how it's being used as well. So we can see that it's being used as base types, or it's being used in a declaration of a field. And we can see it there, and we can navigate to something like that. Not enough space. So we can navigate to the particular code, or we can see that it's being used as a local variable, or as a return type, or parameter declarations, and so on. And this is a very good way of finding out when your code is being used and where from. Let me see. There are other useful things we can do in navigation here as well. It's all context sensitive. So for example, when I'm on a method, one of the other items that is available here is function exits. This is useful for when you've got a very complicated function with lots of return statements. You want to see where it's being used. And you can see now that the return statement is highlighted as well as the closing brace. This is the function exits of this particular method. So we can see that one again here on a slightly more complicated method. And we get to see that the return statements are being highlighted as well as the end. Okay, so let's move on. So the other thing we can do with navigation is have a look at what's available in a particular file as well. So if you, once you get to a file and you want to find something in that file, you can hit a quick keyboard shortcut, Control and F12, Command and F12, and you get a list of all the items that are available in that file, and then you can just start typing and quickly navigate around and where it is. And again, you can just very quickly then find usages of these items. So we have a method there, for example, and we can find usages on those and then navigate around. One thing that is very, very useful with our navigation is that we are not limited to just the code in your project. So for example, we've got monobehavior here. We can invoke our navigate menu here, and we can go to the declaration of monobehavior as well. And this will decompile the code on the fly. And so we get to see now the code that is being used there, so you can better understand what's happening in third-party code so that you can write your code better and more comfortably. Okay, so let's then have a look at some of the editing features we've got. So one of the things we want to do with editing is, again, just let you concentrate on writing the code that you need to write, the problems that you need to solve, and so we will just complete anything that you start typing. So tell you what, let's have a quick look here. So for example, if I wanted to use is paused, I can just type is paused and we find it. If I want to call the update method, I can do that. But we'll also try and recognize types that are with a similar name. So I can use the update method if I want to, and I can complete that and just use it. Or I could actually be using one of these type classes here. And of course, we've got simple code completion then, nice and quick code completion, which we can very quickly narrow down, again, just by typing the initial letters of classes. We don't have to type the full thing longhand. We want you to be really quick and edit your code very quickly and navigate around. So there, and then we, of course, show you what parameters need to be passed in. One of the other things we will do, if we have a look at this particular example, here we have a couple of using statements at the top. We have core.input, tower defense, and using state. If I want to use something that isn't included in this particular namespace, we will still complete it. We want you to be able to just type, and we'll find it and complete it for you. So if you want to bring in advertisement settings, it's used in a different namespace, and you can see there it's got in brackets there, in Unity Editor advertisements. And we'll include that, and we'll just automatically put the using statement at the top of the file. So it's, again, it's about trying to make things a whole lot quicker, and you edit your code and get around there a lot faster. Let's go to... Let me just find some code. Okay, well, let's just add in some. So one of the things we want to do here as well is it's very easy to get into the habit of just cutting and pasting your code. So selecting a line of code and deleting it, or selecting a line of code, cut and move and paste it. But it's very easy to make a mistake with that. So we want to help you with that as well. We want to make sure that you can do things in much more of a safe manner. So if we have some code here, what we can do is we can do something called extend selection, where we can repeatedly press a keyboard shortcut, extend the selection semantically, so we know that you're in a safe block of code, and then move this block of code around. If I press the right button. I'm pressing all the wrong buttons. There we go. And we can move the line up or down. Again, that's not terribly semantic. We want to use that in a more of a blocked manner, so we can actually do it by moving a statement up and down. So rather than editing line by line, we can actually edit statement by statement. And so we can select things and move them up or down. But if we wanted it to be inside the if bracket, for example, we can actually do the same thing. If we put the text cursor on the close bracket, we can then move it up or down and move code inside and outside of an if statement. Again, it's all about trying to make you quicker. Rather than having to edit your code just with simple cut and paste, we want you to be able to do it in much more of a type-safe manner. Okay, so the other things I want to show you then with editing is, of course, simple things like snippets. We have templates which we can expand and we can create new classes for, and I can edit those and end up in the right place, which are nice and easy. if I want to have, say, a list, I can just create a new list, and then I can just do a simple for each, and we'll recognize here that I'm being worked on with a file, and we'll even suggest then a nice variable for you. And I can tab through all the spaces and get into the right place here. Nope, never want boo.lang.list. Okay, so that's some of our editing features. We've got lots of refactorings as well. We want to make it safe for you to edit your code, and we want to help you edit your code and rewrite the code without you having to do lots of hard work. So a simple example of that is a file rename, sorry, a symbol rename, and we've got a simple refactoring for that. Again, we can get at this through the Alt-Enter menu. We can hit Refactor, and we've got a number of items we can do in a particular location. So this gives us our context menu of the items we can do. We can inline variables, so it can be called directly straight from there, or we can rename as well. And we can very simply rename. If it's just being used in a single method, we can rename inline. Otherwise, we'll pop up a dialog. So perhaps those are names rather than. And it's just nice and simple, and it works like that. One of the things which is nice is if I have, no, let's leave that for now. So yeah, so we can do things like renamings and refactorings. We can inline variables. We can rename methods as well. So if I wanted to rename onCurrency changed, I could just quickly do it like that as well. And it'll rename that across the project there. And that's very safe. It knows to only rename this particular method called onCurrency changed, rather than any other occurrence in strings or as variables or anything like that. Excuse me. So yeah, so our refactoring menu is all based on where you are in your particular code, and there's a whole bunch of things you can do which is different and which is exciting. So we can do things like when you're on a method, we can change the signature of the method. And this allows you then to sort of add parameters, remove parameters, change them around, move them around, and fix up your code automatically. Other items we can do in here are things like inlining a particular method. We can move them to different classes, move them up and down the class hierarchy. So if you have an abstract base class or an interface or a derived class, we can move those methods between the classes. We can pull the members up and push them down. And we can convert methods to properties and so on. So for example, if I just create a quick property, let's say it's a string of name. This is an auto property. I can Alt-Enter on it, and I can then very quickly change it to a property with a backing field. And it'll just rewrite it. I can then say, actually, I want that to be called mname. And so it's a very quick way of helping you rewrite your code. And so this is a good example to introduce inspections as well. Again, you're probably familiar with these, with the squiggles and the underlines to allow you to do different things. We will inspect your code. Because we've built this index of everything, we know how your code is being used and where it's being used. We can look at patterns of code and see how they can best be fixed to improve your code. So for example, with here, we've got a property with a backing field, but we can actually say that we can convert it to an auto property. Rider is also pointing out that this property is never used, so I'm going to have two options that I can do here. I can convert it to an auto property, but I can also then remove an unused property as well, and that will then tidy everything up. One of the other things I can do here, which is very useful, if I want to remove an unused property, I can either comment it or actually unuse it. Delete it. And let's swap this back. Oh. Because one of the other things that is very useful is a whole lot of our quick fixes have this extra menu here so that you can do it across not just that one particular instance, but across a file, a property, a folder, or a solution. And so you can then fix everything up across the solution very quickly. Inspections, we have way too many of them. We've got loads and loads, and they might not be what you want. They are very configurable. So naming standards is a good one. So if we have something here with a lowercase n, there, rider's going to say, oh, I've already got a name there. Let's call that file. Rider is now saying that this doesn't match our naming standards. So we try and help you keep your code clean and match naming standards, but you might not agree with our standards. If you want to use a lowercase file, you can do so. You can do a number of things here. In this inspections menu item here, we can disable it. We can add a comment into the code to disable that particular inspection so we don't want to hear about it anymore. Or we can configure the inspection severity, and we can say whether we want it to be a warning, a suggestion, or even hide it completely and don't show it. The other thing which is useful in this item here, wrong one, that one. Let's bring that up a little bit. We can actually change the naming standards directly from the Alt-Enter menu here as well. Just bring up a dialog here with giving you the ability now to configure how this works. So we have a lot of configuration items. We can change the configuration of all the inspections, and so we can work with your code, how you want it to work. And it can change it very easily from the Alt-Enter menu. Okay. So that's all I want to show you for inspections at the minute. The other thing I want to show you is the Generate Code menu here. In fact, let's create a new class for this one. Let's use this one. Let's have a couple of values here. And if we use the Generate Code menu here, we get a number of interesting items that we can complete here. One of which is Constructor, and so if we can do something like we can create a Constructor, and that looks at the fields that are available, and it will give us those as options. We can select those, and it will create a Constructor, which will initialize our fields for us. We could do a similar thing, if I scroll up a little bit, with something like equality members. So if we want to create equality on a class to say that this treat a class like a value, we can then sort of create a whole bunch of equality for us, and Rider will do a whole load of boilerplate that you don't have to do. So this makes it a whole lot easier and a whole lot nicer. Okay, so that's kind of like a quick introduction to some of the standard features that that Rider has. Let's finally get onto some Unity stuff, yeah? So one of the things we do with Unity is that we recognize that you're running a Unity project, and we add special features then to work with this. While we index your own code, we also know about the Unity API as well. And we know about how Unity uses the magic methods and the serialized fields and so on. And so when we have a mono behavior or another sort of Unity object there, we will mark it in the editor. So you can see in the editor here that we have a little icon next to the component itself to say that this is being used implicitly by Unity. So normally what we do is we only index what happens in your code base. But Unity is doing things from outside of your code base. And so we need to tell Rider about all that information. And this is what we do here. We tell Rider that it's being used externally, and we also mark it then so that you can see that it's being used as well. So we can see we've got an icon there to show us that it's a scripting class. And let's pick a better one for that. Whenever we have serialized fields, we mark those as well. And we get to see a little tooltip saying that these fields are being initialized by Unity. And we can see that these are being used and that they're initialized and they're serialized. So we also recognize when we have, say, a private field. Oh, value. You see, we don't have an icon there. It's not a serialized field. We're not going to do it. If I swap that to be public, it's now marked as a serialized field. If I have it as private, but I want it to be a serialized field, well, I've got a quick fix to do that. I've got a context action. I can quickly say, I want this to be serialized. And so we can, again, trying to speed you up and make you work better with your code there, mark it as a serialized field, and of course now it's highlighted. I can also then say, as well, annotate with not serialized, and it's now not serialized either, and my serialized field is now redundant, so I can clean that up and get rid of that as well. So on top of serialized fields, then, we also understand the API, so we can just start typing and we get code completion. So we can quickly now generate the magic methods that you need. So we can just start typing, and it'll find the appropriate method and create it for us. And I can do that and get rid of those. Because if I bring up my generate menu as well, one of the items that we've got down at the bottom, if I just shorten that down, is we've got Unity event functions as well. So I can just keep on, I can click on this, show a dialog, and this will list now all of the items that are available for me to complete. And you'll see that as we go down, we have a description. We have a description at the bottom telling you a small summary of what this particular method does. And we can select several of those, and we'll just create those immediately for you and initialize those as well. And if we hover over the items, we've got the summary item displayed in a tooltip there as well for you. And again, the highlight there telling you that it's a Unity event function. It's being called implicitly by Unity, and it is giving you the summary details in the tooltip. So one of the nice things we do here is that because we know the API, we can also help with you. So if you've started typing it and you've got it wrong, for example, we'll give you an inspection there and tell you you've got the wrong parameters. Perhaps I thought this one was static, and so it'll tell me that this is the static is incorrect, and I can quickly remove that. And then I can also say we've got the bool parameters there. The no parameters, but it's expecting a boolean. I can again quickly fix that up as well. So we know this and we recognize these fields, and we try and help you now in case you've got it wrong before. So if you've typed something wrong and instead of having to try and find where this issue is, we try and highlight it and bring it into the editor and show it you directly. Let's just get rid of some of these. Oh. So one thing that is common as well is to have an empty event function here. And this is not a good idea because Unity will still call this event function. So this is not going to be good for performance because Unity will still make the transition from the native code into the mono C# code, and it's not going to do anything. It's an empty method. So we recognize that it's an empty method, and we tell you that it's a redundant method there as well. And so we can then help you clean that up and make that a whole lot better and cleaner. What else do I want to show you here? Again, we can generate our Unity event functions. We can just simply click on an item there, and we get a list of all the event functions that are available to us, and we can generate those and quickly build that. The other thing I wanted to show you, I knew I'd forget, is if we get an update method again, we'll just generate that. We show a little tooltip with the summary information here as well, but of course, if we want to look at more detailed information there, we can show the quick documentation information, and we've got a click to a link now, and it will navigate to it for us. If we have the documentation installed locally, we'll show the local documentation. If not, then we'll go and look online in Unity's own docs. Okay. So when we traditionally look at a C# solution, this is the view that we tend to see. We have a solution explorer here, which lists the solution, lists all the projects and everything. And we offer this. You can have this, and we can work with all of the files in this, and it's absolutely fine. But we also offer you a different view as well. So if you click on the solution explorer up here, you can then change that to be a Unity Explorer view, and we'll show it to you like the assets view, basically. So it'll be a familiar project view that you're going to be used to from the Unity editor itself. And we'll highlight certain folders as well, so gizmos are special folders, plugins, and of course editor items too. And what we'll do is we'll try and highlight any folder which has files that belong to a different assembly. So if you've got multiple assemblies in your project, whether it's an editor project or whether it's something defined with an ASM def file, an assembly definition file, then we will highlight those in the folder here. So wherever we hit, say, an editor folder, these files will be shown as being part of an editor project. Okay, so the next thing I want to show you then really is some debugging. Because we recognize that you are opening a Unity project, we configure everything automatically to attach the Unity editor. You can see that at the top of the screen. This is the configuration now for debugging. We create that automatically for you, and it's just a single click, and you start debugging. Nope, you nearly start debugging. because I have 2 instances of Unity running, it's asking me which one. I hope it's this one. We'll soon find out. And now I can start debugging my editor. But one thing I want to be able to do as well is be able to switch it into play mode when I'm debugging, and I can do this now just simply by clicking the play button on the top of the file, and that will switch me into play mode. Slowly as it recompiles. I've been editing the project, so it has to recompile the project. There we go, debugger's loading symbols. And we're on, and I can then start the project playing, and I think I've started debugging. Oh, there we go. So yes. Let's just restart that. It's deserialized some data incorrectly, got null references. Oh, and debug. That was why it was wrong. One of the dangers of adding new code. Are we all up to date? Nope. Why haven't that hasn't rebuilt? I hadn't saved the file. There we go. So that's rebuilding now. So we won't get any more exceptions, hopefully. Just clear that. Let's start playing again. Attach the debugger. And if I select something, if I pop that up, there we go. Finally, we're in the right place. So we then obviously have debugging. So it's clearly a very slick process to get debugging, and works very well. But once you've got past your exceptions in your code, then you can debug, and you can then look at your code there. And we've got all the things you'd expect in a debugger. You know, but it's all configured for you all automatically. You can navigate your code. You can see the values that are here. You can go up and down the call stack, which is useful, and you can single step. One of the other things we do which is useful is we show the value of the items actually on the editor instance as well. So you can see it in line as you're working with it. There, and we can single step. One of the other very nice things we can do with the debugger is we have a feature which is this one here, which is enable external source debug. So once we've got that on, we can actually now start debugging third-party code. So I can actually start debugging again. And if I hit my breakpoint, if I go down here, I can see the invoke method, for example, and that's part of the Unity Engine DLL. We can see that's part of Unity Engine core module.dll. I can sort of double-click on it. I can then see now the code that is actually part of the Unity Engine itself. And we can debug this, and we can set a breakpoint, and we can go for it. So let's put a breakpoint there and continue. In fact, let's see if there's a better place to put a breakpoint. That'll do. Let's run. And if I call it again, there we can see now that I've actually got to hit a breakpoint inside Unity Engine itself. So this is a great way of being able to debug third-party code, see what's happening when you're calling other people's APIs. So it's great to be able to debug your own code, but sometimes you also need to be able to see what else is happening around the place and working. Okay, next feature I want to show you is behind this thing here. Right, so let's just clear that. Again, it's about the idea of trying to bring in the information which Unity already has and is working with code, and bring it into your script editor so you can have it close to where your script code is. So for example, if we start the wave running, we can see we've got some log messages being written out here, but they're not very useful. We've got a stack trace, but we can't really do much with it. But fortunately, we've brought the console into Rider as well. And so as the events are being logged, we're capturing them in Rider and showing them here. And even better is we've got a stack trace which you can then click on and navigate with. So we can use this sort of like hyperlinks to navigate around your code and be able to find and use the information that's being logged for you. And you can then click not just on the file names as well, but also on the method names or the class names, and that will help you navigate around and find where you need to go, which is very useful. So the last thing I want to show you then with Rider is on a different project. So this project we've got here, and this is with a unit test project. So we've got unit tests which we can run inside Unity. Unity itself requires you to run tests in through the Unity editor instance. Because you're using the Unity API, you need the engine running underneath everything. So you can't run it in a standard NUnit test runner. You have to run it through the Unity editor instance. We've brought that into Rider as well. So this is now just the code for that particular project there, and we recognize tests in the editor. So we've got little icons in the gutter here. When they're marked with a test here, we put a little icon in the gutter, and we can say that we want to run or debug it as well. And so we can run those tests and have them run in Unity. Again, Alt-Enter is useful for running everything. We can run all, and it will go off and it'll talk to Unity and get Unity to run those tests for us, but actually report everything in Rider. So you don't have to swap between Unity and Rider to be running your test there. And when we're green, everything is good. When our tests pass, everything's good. But when we have a failure, again, in fact, if we have a look at a failure on the Unity side, again, we get a block of text which we can't do anything with. That's not terribly useful, and to get that over into our editor and to get where we need to be is tricky. So we can actually, but because we've got it in Rider, we can parse that information, and we can just click and we can find where the error is and then quickly fix that up and rerun the test. If we build it first. Is that building? Let's hit refresh and build. And hopefully green. Yes, fantastic. So we can run our test there. We're bringing this information in. Right, so that's very quickly everything that I've been showing you. The sort of standard Rider features that we've got, if you can remember 2 keyboard shortcuts, you'll be able to get to pretty much anywhere else. Shift, Shift, and Alt-Enter. They are the keyboard shortcuts that are useful to know. We do a whole load of things. There are things I didn't even show you there. There's version control, for example. We integrate with all of the usual version control providers. We also have this idea of local history, which keeps a local copy and snapshot of your code. So as you are editing it, you can roll back to 5 minutes ago. You can roll back to 2 days ago. So it's a very good way of working with your code without having to check in all the time. Just check in when you need to check in. And then, of course, we have all of our Unity features as well. The log viewer and the switching to play mode and the test runner. This is what requires the DLL that we install into your project. We support debugging. We support debugging over the network as well, so attached players. We work with that too. Showing where the code is being used and where the serialized fields are. Generating code. Inspections. Yeah, there's a cool one there. Color highlighting. Quickly show you that one. I like this one. This is nice there. So just a simple one. When you're using colors in the editor, we give them a highlight. But then we can also pick it from a color palette, and we'll rewrite it and show it there. It's a nice little feature, but I like that one. Oops. And we do the same thing in shaders, actually. I'm running out of time, so I won't show that. Link to documentation and various other things. We are still building this. We've got a whole bunch of ideas of things that we want to build, some things that we would like to put into there. If you can think of ideas and things that you would like to see as part of Rider, please let us know. We're on GitHub. The Unity support for Rider is actually an open source project. You can raise an issue. You can let us know and let us know what there is. I've got some more. I'll show some more links at the end so you can grab them. Useful information. You can download a 30-day trial version. And the link is there. There's an English version of that page, which is just jetbrains.com/unity. If you're a student, you can get all of our developer tools, all of our client IDEs for free. So you want to go to jetbrains.com/students, you can get them for free. If you've just graduated, we also offer a discount. And contact then our partner for more details about Unity and Rider here. And so that all ends up to me to say thank you, and we'll have a look then to see if there are any questions.